Welcome. My name is Bob Tickleman. I'm a Microsoft Principal Technical Trainer. I'm excited to be your guide for AZ-204's Learning Path number 10, Develop Message-Based Solutions. While there's two different queues we're going to cover in this module, it is a messaging module specifically about the different types of queues. And as I've done in the other types of queues, I'm going to just take a quick break. I'm going to go explain where that fits within the entire queue process. And then we're going to jump back into the course material, and then you'll have a lab to perform. As we've talked about in other recordings, the modern application design is to go to microservices. And so what I have here is a representation of a front end represented at the top by the triangles, the different parts of a end user engagement website. I got my middle tier across those circles where I have my business processing, and I have my system of records in the back end or the bottom part of the screen. Now, I've advanced partway through the build of this story, which I would have told in other parts of the recordings. And what I want to take a look at this term called decoupling. And we've done this a couple of times at different phases to decouple the direct correlation of an app potentially communicating with another part of the application, because it would require them to scale at the same time, at the same level, when we may not need that. So for example, having millions of users coming to my website because I appeared on some celebrity's favorite list, and all of us having millions of users coming to my website, I don't want to have to be able to support those requests going to maybe a backend SQL database. So how do we decouple these activities? And we've talked about some other kind of things you're working with, and I want to look specifically at a sales order. So let's say I had 1 million people come to my website, of which 100,000 people put something into their shopping cart. That shopping cart then goes to what's called order fulfillment. Now that order fulfillment is actually broken up into two pieces. We have to do order verification and then order completion. So those are two different features. And I've talked about in other parts of this class, maybe doing something like, I'm going to actually charge your credit card. And before I charge the credit card, I'm going to run a thing called an Azure function, going back to another recording where we talked about Azure functions, that's going to check the credit card input value on your application. So I've got a whole bunch of stuff happening over here, and you can see I've broken it up into several pieces. The first part is going to verify that all the information that I've collected from the user is what I needed. So I've collected to make sure I've got their name and their address and the ship to location. I've got their billing info. I got all that. These are the number of products that you want. This is the quantity of those products. And so once I complete that, I don't need to run that against the database because, again, it's going to directly couple the order itself from the actual order fulfillment piece. And so what's going to happen is, by splitting this up, I'm going to verify that that user has got what they wanted. I'm going to send them an email saying, here's your order, here's the order number that you have. And now what I'm going to do is I'm going to split up the second part of this and decouple it from the actual completion of the sales order. Now what's going to happen is I'm going to have to maybe have that Azure function that's going to check the credit card number and make sure that it was valid, and then send it off to the credit card processing environment. And then what I'm going to do is I'm going to take that order and I'm going to place that order into a queue. And so you can see that I'm streaming a number of orders to the actual queue itself. Now this is great. I've now got an ordered list in the sequence of FIFO, first in, first out, of all the orders that have been processed. What I then want to do is I want to then process those orders in sequence. Now, just building on this story, we said 100,000 users wanted to put things in the shopping cart. Let's say 10,000 users actually went to purchase something. And just to keep my math very simple, this item that was very hot that everybody wanted, I only had, let's say, 1,000 of those items in stock. So in my record, in my database, I only have 1,000 of those. Now, if I was directly coupled, only 1,000 of those users, if they were only each allowed to buy one, only 1,000 would have been able to complete their orders. The rest of the users would have had an error saying, I don't have that product in stock. And so what happens with that? the statistics show that you have 3 attempts before an abandonment of an order if it can't be completed, if there's some kind of error or some problem, maybe, processing the credit card. After 3 failed attempts to complete the order, users will actually abandon the order itself. So I don't want to avoid that. So this is why I want to decouple the actual order fulfillment. I now have all 10,000 orders put into the queue, and I can take a while to do this. So I don't have to do it at that moment in time. And so let's say I have an SLA, a service level agreement, that says all orders will be processed within 1 minute. I might have some application, might be an Azure function or whatever. Once items start to appear in the queue, it's going to listen to the queue and respond to the length of the queue. So let's say, just again for math perspective, I can do 60 orders per minute. I've got 10,000 orders in there, so I'm going to need to scale this application to support. If I do 60 in 1 minute, I've got 10,000 in there. I'm going to need multiple instances of this application to fulfill those orders in 1 minute. So I'm going to have to multiply this several hundred times, maybe 100 times, to be able to get to that component that I'm dealing with. And so I can now start pulling these items in order out of the queues you're working with. So again, why do I need to decouple? This is the reason why we do this from a message perspective. Now, this is different from the other types of queues that were just responding to something being created. An item was created in a storage account and I needed to actually do image recognition against it. The image didn't live in the event queue, just a record of the event taking place. This item was created in the storage account and it's the name of the item. The item doesn't live in the storage or in the queue. It's just an event that this item was created. The difference here is, as a message queue, the actual object that lives in the queue is the message itself. It's a body of data that you're dealing with. And if you remember back on the event grid, we talked about the schema, this very tightly controlled ordered list of values that are on that schema that you're dealing with. So here is that scenario we're taking a look at. Now, we have several queues that are available for us to do this kind of processing. You've seen me on this screen before in the other recordings. And so we've talked about our event-based queues of event grids and event hubs. The other types of queues we're going to be taking a look at in this module, and we're going to spend the vast majority of our time on a service bus. A service bus is the enterprise-grade capability of what it is that we're taking a look at. The ability to store a record or some information into the bus, and it guarantees FIFO, first in, first out, so order of processing. The size of the message is going to be talked about, how long you can keep that information versus a thing called a storage queue. We're going to do all of these together. We're not going to split it up because there's only, I think, one slide on storage queues, and then you've got labs to each of these. Now, I've added to all of these recordings a bit about IoT Hub. We used to use IoT management of their events using event hubs. We've now created a specific queue for IoT Hub because it provides both a pull and a push. It's a two-way communication. Your IoT devices put information into the IoT Hub, and we can now push back configuration and control information back to those devices. None of these other queues do that other than just messaging, yes, I've done something with the message. But as far as pushing back control to it through the message queue, you're not going to be able to do that. So this is going to show you the message queues. You understand what they are. It's actually a body of information that lives in the queue. And we'll go now take a look at the books, and then jump back into an exercise for each. So our goal here is to make sure that you can pick the right type of queue to meet the requirements of your organization. Both have the ability to store a message in them, but the size of the message is going to come out through this, as well as the volume of messages that you're working with. Now, this has changed, especially for the service bus, has significantly grown in the size of the queue itself, as well as the size of the messages, depending on the tier that you're going to be working with. And we have a slide that will get through this. But I would say, for me, it's a very clear distinction. If it's in a production-ready enterprise grade that you're looking for, you're going to service bus all the way, because you're going to get data letter reckoning and a bunch of other features that you wouldn't get in just the Azure Storage Queues. So when we take a look at the books are providing the two different types of queues for us. We have Service Bus, which is that enterprise grade, and Azure Storage Queues, which are part of an Azure Storage account, which we had covered in other modules earlier. A storage account is a regionally based unit of storage that has a replication model. We had the ability to have blob storage, or what was called container storage. We had file shares. We had tables, which is very similar to Cosmos DB and that name value pair. And we had the ability to have queues that were in there. We'll have an exercise that you'll be doing to create that and populate it with some messages. So when you take a look at Service Bus, as I said, is that broader aspect of messaging. It has the pub sub subscriber model that you're dealing with. So it is, as I said, that enterprise grade capability you're dealing with. When considering the choices, there is no choice for me, at least at the production side. If you are an enterprise grade, you're going to want the actual Service Bus providing this for you. The FIFO capability honors the order in which the orders came in, guaranteeing you that that customer would get the expected items, especially if you had a shortage of those items, you would fulfill those first orders that came in. So lots of reasons to have that FIFO capability. I want to spend a few minutes looking at that very last piece, and you'll see this as you go into the lab itself. I'm not going to do a demonstration to show this to you, but if you take a look at the different variations of a Service Bus, there's a basic, a standard, a premium, there's different tiers that all provide different capabilities for you. And that's where you're seeing some of those differences in the numbers at the bottom. So you can have a message that is either 64K in size. So that's quite a bit of text that can appear in that message. But if you have a large amount of information, you might need to upgrade from the basic tier of the Service Bus. And we have them that supports up to 100 megabytes of information in that bus or in that message itself. So they only list up to 1 megabyte, but you can see that there are ones that actually go much higher on the next slide. Other considerations for using storage queues themselves is they support large volumes of information. Now, a queue typically only supports up to 80 gigabytes. So the Service Bus, there are queue types at the higher enterprise levels that you can have more than 80 gigabytes, but typically an Azure storage account is, for all intents and purposes, unlimited. So if you have at the lower tiers of Service Bus, you might have a limitation of up to 80 gigabytes, and you'll see that again on the next slide itself. So here's that comparison of the Azure Service Bus, the premium and standard versions, that you can get up to that 100 megabytes worth of message size at the premium version. You have higher throughputs that you're dealing with. It has fixed pricing that goes with it versus pay-as-you-go. So a number of different choices picking the tier that you're dealing with. When you take a look at Service Bus, the queues, the topics, and subscriptions, this is a standard form that you've seen throughout these series of queues that we're dealing with. We have publishers that publish information in the form of a thing called a topic to the queue itself. And then you have subscribers. So in my model that I showed you at the beginning, where I had an order fulfillment process, that order fulfillment went through and did order verification, guaranteed that the billing information was correct. It actually charged the credit card to make sure it could be processed. It validated the ship to address, got all that information, sent the email off to the user and said that your order's been fulfilled. It then took that order and then put it into the queue. So that would be my publisher in this case. The topic would be, in this case, the order number possibly, or some indication of that item itself. It sits in the queue. And then what we're going to have is a subscriber that looks to the queue. And if there's items that are in there, it may have one, it may have scaling capabilities as I described. It says, hey, I have a subscriber that needs to scale out to meet the SLA to process all these items in the queue. And if there's only one item, you only have one. If there's 10 items that are in there and you can do 6 a minute, you're going to need 2. So it can actually scale depending on the need of the length of the queue itself to meet your SLA. So that whole process of the queues, the receivers, the topics, the subscribers, and any rules and actions that you want to put around the subscribers themselves. As I said, you might talk about ways to have it scale. When you take a look at message routing down that left-hand side of the column, there's several ways that message routing and correlation patterns can take place. They list 4 very specific ones, and you'll see that they're similar. Some are just simple requests and replies. You have a multicast requesting a reply, which is going to have a variation of the prior one where you have this very specific message. It simply replies that it's been processed. You're going to have a multicast that you might have multiple subscribers that could get that message, and then you could reply back to that message has been pulled out of the queue and been processed. You get into multiplexing, and this might be because maybe you have several items that are in the queue that need to be processed together by the same subscriber. And so we have different ways to handle that, to send those multiple messages to the same subscriber to make sure that they're either batched or handled in a similar pattern. There's a feature for payload serialization. And what that's going to do is to take something that might be unserialized and provides a serial payload to that item. And then as it gets pulled out of the queue, you can remove that serialization, but it's just a way to handle the items in the queue itself. Now, a completely separate topic, we then get into Azure Queue Storage. Azure Queue Storage, as I said, is part of a storage account. It'll be a regionally based unit. And you can see that some of the numbers there, you're going to access it over a URL. And that's very similar if you remember, https:// it's the storage account name in this case, .q.core.windows.net, where in the case, if it was a blob, it was the storage account name .blob.core.windows.net. Same thing that you could do with the storage account. You could create that and put it on a private endpoint, so you don't have to access it using the URL if you wanted. We had storage size that you're working with, and you can see that you had different capabilities for the storage account itself. There's the size of the message at 64K, it's a hard limit, and you're not going to get that serialization of the items that are put in there. We have a set of libraries that are going to be available for you to manage the queue, from placing items into the queue, identified items in the queue, removing items from the queue, and processing them. So you've got the different libraries to handle the different activities you want to perform against that queue. And now we have 2 separate labs. We would normally split this up, but they're very small sections. We've got a exercise that is going to be sending and receiving messages to an Azure service bus that you're working with. And then we've got another one that is going to actually send information to a storage queue itself. So we're going to do those 2 labs now, and then we're going to come back and close this out.
Before I do the demonstration on how to use a service bus, I want to actually go through the steps and talk about some of the features that we showed in the creation of a service bus. I'm going to create a new resource. Select service bus. As with all resources, I'm going to have to create a resource group, the subscription, and give this a name. You select your region that you're working with, and then you want to take that pricing tier. And if you remember on this slide, we talked about the various pricing tiers and the features that come with them. Let's take a look at what they are. I'll just scroll down so you can see them all. But when you take a look at the basic, standard, and premium, they take a look at the size of the messages we talked about and the costs that come along with them. I just want to show you some of those values. I'm going to select the premium tier here. You'll see there's not many other features that you have to pick. I'm just going to quickly show you some of the tabs. There's an advanced feature, networking. I'm just going to jump over to review and create. This actually happens fairly quickly compared to other services that have to be built at this scale. So in real time, that was about 2 minutes for that to take place. We're going to go to the resource now. And we've seen a number of these standard features in the blade construction. I'm going to actually come down to entities. And so in here, you get your queues and your topics. I'm going to create a queue. Call it RJBT SBQ. We can change the size of the queue depending on the license that we provided for it. I'll keep it at default. See some of the other values. We have things like the days that the messages are going to live. We talked about a feature called dead letter reckoning. All of these are capabilities that you can create on the queue itself. I'm just going to leave it the same. And so now I've got my queue. And if I had items in the queue, and we'll be doing this in a few minutes where we'll actually show you the queues, but this is where I would get into it. So let's actually do the demonstration of writing an application where you will put things into the queue and pull them out. In this lab, you're going to configure an Azure Service Bus resource and then build a .NET application to send and receive messages to that queue. Let's get into this. I already configured my Cloud Shell in this environment, so if you've never been in here before, you may get asked to provide some information to be able to get in here, but I'm already in. The first thing I want to do is instantiate a number of variables that I'll be using in some scripts that I'm going to be running. The next thing I do is create the Service Bus messaging namespace. And the next thing I'm going to do is go in and show you that the bus has been created, but it won't actually have a queue set up in it. Go into my resource group. Here's my service bus. And there's my queues. Now that the namespace has been created, I need to create the queue to hold the messages. I'll go back up here and refresh this. And there's my queue. Now I need to retrieve the user principal name for the account that is going to represent the role that will be assigned to it. This is going to retrieve the resource ID of the service bus namespace. Then the resource ID sets the scope for the role assignment for the specific namespace. This command is going to create and assign the Azure Service Bus Data Owner role. This command is going to create a directory to contain the project and to change to that directory. And this is going to create the console application. These commands add the azure.messaging.servicebus and the azure.identity package to the project. This is going to allow me to edit the program that I want to run. I'm not going to remove this code and put in my application. Okay, so I've got the code in there. I'm going to save this. So I'm actually going to open up the queue now. And let's see if we can see these items coming in. Okay, let's run the application. So it's going to create 3 messages, refresh. So we can see that we have 3 messages in the queue. And we can now see that there are no messages in the queue. So that ends the lab. We saw that we created the queue, we created an application, put items in the queue, and then removed them from the queue. In this lab, we're going to create and configure an Azure Queue Storage resource. Then we're going to build a .NET app that sends and receives messages using the azure.storage.queue SDK. And you're going to learn how to provision the storage resource as well as managing the queue messages. Let's get into this. I'm going to start off by going into the Cloud Shell. I've been in here before, so there's no pre-configuration that I needed to do, but if you've never been in here before, you'll have to do that. I'm going to start off by instantiating a number of variables that I'll be using for the resource group name, for the region, and the name of the storage account that I want to create. This command is actually going to create the storage account. This command is going to retrieve the user principal name from the account, and it's going to be the one that gets the role that'll be assigned. This command will retrieve the resource ID of the storage account, and this resource ID sets the scope for the role assignment to the specific namespace. And this command is going to create and assign the storage queue data contributor role. These commands are going to create the directory to contain the project and then change to that project directory. This is going to create the .NET console application. These commands are going to add the azure.storage.queues and the azure.identity package to the project. This command is going to allow me to edit the application. I'm going to replace this blank code with the code for the application. I now need the storage account name, and I'll go get that from the storage account. replace the storage account name. I'm now going to add code to create a queue client and to create a queue. I'm now going to add code to send and list messages. I'm now going to add code to update a message and list messages. I'm now going to add code to delete messages and the queue. We're now going to run the application, and it's going to give us an opportunity to create 3 messages in a queue, edit one of the messages in the queue, and then delete the 3 messages in the queue. So let's see how that works. So I've just refreshed the queue. You can see it up top here. So the queue has now been created. So I'm going to continue the app and add 3 messages to the queue. I can go into the queue. And I can see my 3 messages. And there's the 3 messages. So I'm going to update one of the messages in the queue. I'll refresh this. You can see that that message has been updated. And there you can see the pull from the queue itself. And then I'm going to delete the 3 messages from the queue. I'll refresh that. The messages are gone. I'm going to go back out just so that I can delete the queue. So there's the queue. It'll be disappearing in a second. And I'll refresh this. And you'll see now the queue is gone. So that's our lab. Let's return to the recording.
Welcome back. We're going to close out this module and take a look now at the knowledge check. Question number 1. What advanced feature of an Azure Service Bus creates a first in, first out, or FIFO guarantee? Go ahead and pause the recording. The answer to this one would be the message sessions provides that ordered sequence of the first in, first out guarantee. Question number 2. In Azure Service Bus, messages are durably stored, which enables a load leveling benefit. What is the benefit of load leveling relevant to a consuming application's performance? Go ahead and pause the screen. That benefit is that decoupling that I've talked about. It's the ability to separate a potential load at the front end, having to have a corresponding increase in load at the back end. If I don't need that immediate response, I can now put items into the message queue and then be able to pull them out. And as long as I have a defined SLA, I can have the back end scale at a completely different level than the scale that happened at the generation of those messages. So that brings us to the end of the module. We've now taken a look at a type of queue in which information is going to be deposited into the queue itself, not just a record of some kind of activity. This is a message queue that came in the form of 2 different levels, an enterprise grade using Service Bus, and more of a kind of an entry level or not mission critical grade in a thing called a storage queue as part of a storage account. There's some significant differences in the size of the messages as well as the size of the store of the queue itself, and characteristics like a first in, first out guarantee, dead letter reckoning, and some of those capabilities. So there are 2 different queues that still allow for that decoupling capability that separates the performance of some system that generates the message as well as then the application or the response to the generation of that information, and then passing it along by maintaining that information in the queue itself. Thank you for joining me on this journey of queues, and I look forward to seeing you at a future recording.